Hello everybody and welcome to our next class. So today we're gonna do two separate topics. We're gonna be talking about visualization tabular data and repeating actions with loops. So let us start with the visualization. There is a really nice quote by Richard Hemming, that was a famous mathematician who was working in the computer science, who basically found the computer science, and his quote is, "The purpose of computing is insight, not numbers." And that actually is true for mathematics in general. I mean, people, when they look at mathematics, they see, you work with numbers and with all this weird stuff that nobody cares about. But the point is, those are just tools. What the mathematics is trying to achieve and the computer science is to get some insight into the data, into the problem, to figure out how things work. So anyway, today we're gonna be doing the visualization of some of the data from our inflammation set. So again, we need to import the NumPy, and we store the data about our patients into the data variable. And next, there's lots of different ways, right? How to view the data. And as we will see, depending how you look at them, you might spot the trends and the information. You might get the insight into the data easier or harder. So we're going to take a look at different ways. So what we're going to be using for this is the matplotlib library. This is a standard library that basically everybody uses in Python. And we're going to have separate lectures about that later on in our course. Today we're going to just take a look at some basic functions, so you can already start to make some graphs and get some insights. And so instead of importing the whole library, we are interested only in one module, which is called the pyplot. So we're going to import matplotlib.pyplot. Again, with this notation, that means we are getting some module pyplot from the matplotlib library. What is a pyplot? Simply put, it is just one way how to control or how to work with the matplot library. And why it is useful is because it uses the same kind of command style like the MATLAB. Maybe you have heard about this program. It's kind of old. It's been here around for a long time, even before Python, I would say. So MATLAB is used in lots of applications, so people are used to it, but actually it's sort of a one-purpose program, only for some computation and showing images and stuff like that. So Python is much more versatile. But because people already know MATLAB, so why not to make it easier for them? So using this pyplot, if you know MATLAB, is very easy for you to make the graphs and so on. All right, so we import this library. And then the next thing is we use this function, which is called imshow, and which is from the pyplot from the matplotlib, and we feed it the data we have. We feed it the data from the CSV file. That's the input of the function. And what we get is an image. We call it image. Well, if you look at the syntax, that means image is a variable, and we created some object, and this variable points at this object, right? This is a function that creates some output, and to be able to attach that output, we have this image. And then to visualize this image, whatever we have just created, we call this function matplotlib pyplot_show. Okay, so let me run that. And what we got here, this is a heat map. So this imshow, it gives you a heat map. I think you must have seen heat maps before. Basically, heat map, it tells you by the colors, it tells you, it shows you the scale of the numbers, right? So here, basically, it helps you to see a three-dimensional graph, right? Here we have number of days, 0, 1, 2, 3, up to 40 days. And here we have the patient 0 up to patient 59. And so going across the days, you see that in the beginning, the low numbers, there should be some legend. We're going to talk about it. So here is no explanation, but let me explain you. So when it's the dark blue, that means that there's a low inflammation, and as the numbers rise, they go into yellow. Probably you've seen in heat maps, if numbers go really high, usually they go to red and then down. So you see the inflammation goes up and down for each patient. And for example, the highest inflammation then we can see across all the patients is somewhere around the 20th day, so somewhere in the middle. At this point, you might wonder, what this object here is. Like I said, we have a variable image assigned with this object that was created by the function. Well, let's just take a look at it. So we do print type image, and so you see it's from the class matplotlib image axis image. That maybe didn't help us very much, but now if you take this, you can take this and you can put it in Google, and if you want to know more details about it, you can find out. We will find out later. If you don't know what this class means, so class is the type of the object. So we have a class integer, we have a class class numpy array, class string, and so on. And we will be actually making our own classes later on in the course. But at this point, you don't have to care about that so much. Okay, so next, let us take a look at other type of graphs, and those are the line graphs. So, here on the heat map, we see that the inflammation is rising towards the mid time, and then it goes down. So now, let us take a look at some kind of averages, because also, looking at one patient, there are differences in the patients generally, right? And some patients could have quite different data from the others. So what is quite useful is to look at some averages. So here we go back to what we have learned last time. So we have this mean function from NumPy, and so we're going to do mean across the 0 axis. The 0 axis is the patient axis right here. So the mean is going to be calculated going across the rows. And then we can plot a simple line graph. For that, we have this function called plot, and we give it this variable where we put the mean value of the data. Maybe let me add here also, so print AVE inflammation. We know what should be in the AVE inflammation, but maybe it's also good to take a look at that, because sometimes you write the code, you make a mistake, you put the wrong axis than you wanted. So it's good to be checking the data, throughout, to be looking here and there what's in each variable before you pass that variable on to another set of action. So here we see that, within those 40 days, it goes up and down. The peak is exactly in the middle. And it's a bit strange, because we see basically a linear growth and linear decay, which is something, with the disease, you would think that there would be a fast growth and then kind of a slow decay, right? People usually get sick very badly fast, and then the recuperation takes some time. Depends. So of course, one thing could be that the data might not be correct, right? That's another thing that we will be looking at. Another aspect is that you get a set of data, and generally, even if it was you who obtained them and set up the experiment and got the data, you cannot be really sure if the data represent the reality or not. And that's why we are trying to check the data. We will be sorting them. And in future, we will be also putting out the data which is not relevant. We will be able to spot data which actually are some kind of this, what we call the outliers, which are very special, and they are not really of a big interest to us when we want to spot some kind of a pattern. All right, so let us take a look at more of these line graphs. So let's make another line graph. Now, this time, not without the mean over all the patients, but let's go with the maximum. So how it went with the maximum? Well, that's an exactly linear growth and linear decay. And as for the minimum, okay, so we have like the minimum, it steps up and then it steps down. So yeah, I mean, all of these are, they make sense like this together. But yeah, we will see later on, looking at the data, looking at the other data that we have, yeah, if this is really the trend, how this disease progresses, or not. So the next obvious step, while we are able to do these single graphs, is to put them together right next to each other, over each other, to be able to compare them, easier. So to group them, we can use the following way. So here is some code. So let me go through it, and to really understand it better, how it works, the best way is to play with it. So again, we import the NumPy, the Matplotlib pyplot. I mean, you would not have to do it, but let's say if this is your first code, nothing else you have written so far, we load the data. So first, we create here this figure, using the figure function from pyplot. What this does, it creates a canvas. It creates a place where you will be putting your graphs. So let me run the whole thing. So now you see, so at this point, we have these three graphs together, but let's not focus on that. We're gonna get there. First thing is this canvas. So you see this canvas is 10, it has a size 10 by 3. So let's change that to 10 by 5. What's gonna happen, right? And now you see that the width is now, it's taller. I'm sorry, it's taller. So you see that the 10 here, that represents the width, and the 5 represents the height. So if we do it 10 by 10, right? Now it's exactly the same width as is the height. The whole picture, the canvas, you can imagine that like that's the paper where you draw the graph. So through this fixed size here, you create the paper on which the graphs will be printed. Okay, so that's first thing. Now you want to be adding the graphs. You can add 1, 2, 3, 5, or million. I mean, as many as you wish. You're gonna do that using this function add subplot. Yeah, for the fig has this function add subplot, and that's where you're going to be putting them. So first you have to create them. So now here it has 3 parameters. So these parameters, they tell us about the grouping of the pictures, how you want to have that. So here we have the pictures in the line next to each other. So the way how Python stores this information, again, it uses a matrix, right? So this is like a matrix with 1 row and 3 columns. So here you see, so the first one is number of rows. Yeah, so it is a 1 row. The number of columns, 3 columns, and now this number here tells us in which column or it's going to be. In this case, generally it just tells us in which order where that graph is going to be. So if you now compare all of these trees, you see that all of them, they have 1, so that means 1 row. All of them, they have 3, which means 3 columns. And this one says it's going to be first, this one second, and this one third. So let us verify that. So what if I'm going to put here, this one I want to be second, and this one I want to be first? What happens, right? They change the position. Now they change the position. So we see that that exactly works like that. So here I put it back. So this is first, second, and third. And now the important thing here is, so it's up to you how big canvas you want. I mean, I'm sorry, how many graphs you want to put in and in a what way. What we could do is so let's do 2 rows. So let's do 2 rows. And we're going to have a matrix with the 2 rows and 3 columns. And let's run it now. So now, okay, now the picture didn't really work out that well. But what I want to show here is, so let's say I want this guy to be first. So we have 2 rows and 3 columns. So this guy is going to be a first one. Then second one, I want empty, and I want this guy third. And then this last one, I want to be in the beginning of the second row. So I put here 1, 3, 4. Let's see what happens. You see? So now there is no guy here on this position, and there is nothing on this position and this position. And now if I want to move this graph, for example, here, this is position 1, 2, 3, 4, 5, so I'm gonna put 5. Yeah, here could be now a bit confusing that, yeah, this position counting does not start from 0, it starts from 1, all right? And now you can put, so you can either put here another graphs, or you can just leave it like this. And so you can make this, partitioning of the canvas in whichever way you want. You just, it's just what you write here. Thing we can play with is, what if we put a different partitionings here? So I think generally people don't do that much. And well, let's see just what it does, right? So here we're claiming that we want to put all of these into in a 2x3 matrix. So, but what if we put here, for example, here a 1x3, and as you can see, that gave us an error, right? But it's not always like that. So let's say that we put this to 3x3, and now you see it didn't give us error, and what it gives us actually is a user warning. User warning is a different thing than an error, so let's read it out. Tight layout not applied. Number of rows in subplot specifications must be multiples of one another. So we must have multiples here. So for example, that means we can put here 4. And now you see it works. I mean, it gives a different outline than you might want to, but well, so this is up to you. So you have to play with this. I mean, standard thing is just to put them all in the same, put in the kind of split the canvas into the even matrix for all of these, for all of the subplots that you're gonna put in. All right, so we covered the canvas. Now we've got the subplots, and now for each of these subplots, well, we have to put some plot in it, right? We have to put the data in it. So far we didn't do it. This created the canvas of a certain size. This told us that this object that we call axis 1, or that is stored in this variable axis 1, is going to be in the 2x3 division, and it's going to be the first one, this the third one, this one the fifth one, but it has no other information, right? So then here, for this object, you call the plot, and now here you give it the data. And so the data are, for example, the mean, the max, or the minimum of our data. So that's the same as before, right? If we go and look up here, this would have been matplotlib pyplot.plot, and here we would give the data. So here is the plot and the data, but now it's part of not the general pyplot, but of this axis 1 object here, axis 2 object here, axis 3 object here. And as you can see, we already start to give some labels. So this is how you can set some labels. So you see set y label average, and then it shows here an average. We can, and we have it for all of the other ones. We can also add, right, axis 1 dot set x label. Here we put days and run that, and now you see it gave us the x label. So this is like in math, yeah. This is for the graph. This is the x. This is the x axis, and this is the y axis. So the x label is here, and y label is here, and you can put them. You don't have to put them. It's up to you, right? And then there are these last things that we have here. So here is this thick tight layout. So that allows the graphs to go kind of nicely together. So let's see what that does. If it's not there, right? They are kind of, I mean, depending on how you set them up, they would not be, the layout would not be so nice. Depending on the application, you might want to have it, you might not. You see, they were a bit more cramped before. Now they are a bit more evenly spaced. And so the last thing here we have here is for the is to show the plots, is to show the actual whole image. But before that, here even have this matplotlib pyplot savefig, and here we put some name. And so here we can, not only we can generate this picture here now, right, into our Jupyter notebook, but we can also save it. We can also create an image, which now you can put on a web page, you can send to a friend, put an email, put into a print. And so this here in your folder now created a PNG file. Where am I? Class notebooks. This is a third class. And so you see I have here inflammation PNG. If I'm going to open it, you see I got exactly this picture. Just be careful, right? If you now, if I'm going to now change this. So for example, I'm going to do the original 1, 2, 3. I run this. This does not tell you there is already the file. It just rewrites it. Yeah. So you have to be careful about that. As you can see, the file just got rewritten. So there will be other neat tricks. You can have some dynamical naming and stuff like that, but just simply this will just create this file. And if there is a file of the same name, it's just gonna delete that. So be careful about that. All right, so that's all about the graphs for now. And now let's get to the next section, which is called the repeating action with loops. And so now we're going to talk about loops, looping, and that is connected with the following problem. So let's imagine that you have a variable word, and we put this word here, this string lead, right? And now what you're supposed to do is you're supposed to print each letter of this string separately. You should go through the, what you want is to go through the string and print first letter, second letter, third letter, and fourth letter. Of course, you can do it in the following way. You just write print word 0, print word 1. I mean, we know that this is a string and we can access it using the indices. So yeah, this is gonna work fine. But that's a lot of repeating code, right? The difference between this line and this line is just in the index. And on the next line, again, the difference is just in the index. And again, the difference is just in the index. So it feels like a lot of wasted space that we wrote all of this. And even if you said, well, okay, I mean, the computer, it can handle lots of text. Well, it's just true. Why not? I give it to you. When we write a code, we want the code to be useful the next time. And not only to our people, but not only to other people, but also even to us. And so what if I'm gonna change this word lead and I'm gonna change it into hello? Now, what happened? I mean, now this hello, it has an extra letter. And so if I'm gonna run this code, I will not get that extra letter, right? So now I have to rewrite that code. I have to add print word 4. And what if I change it? I change it into a shorter word. Now I'm gonna get an error because the string index is out of range, because I'm trying to reach the string with the index 3, and it's not there, right? And so again, if we take a look at this, I mean, this is a repetitive action, and this is exactly the core of why we use computers. Because computers are great in repeating things 10 times, 100 times, billions of times. That's the whole idea of a computer, is to repeat things till you just cannot anymore. All right? So that's if computer is about something, it is about repeating things. So we also have to write the code in a way, in an easy way, how to be just repeating stuff, right? I mean, that's why we want to use computer. I mean, if you use computer, I mean, if you're supposed to sort 1,000 files, always look at the name and put them where it goes in the alphabet. I mean, that's horrible work for a person, right? That's why we have computers. The same way, if you're making a cars in a factory, and at the whole thing just, it goes over and over and over, and all the same things, you have to repeat it, and that's horrible for people. I mean, we do not like repetition. I mean, you can say, okay, in sports, I mean, it's a practice, but you know, even a sportsman is not gonna repeat, it will not do just that, right? So anyways, sorry, going back to back to our problem is, so we want to do this, But we want to do this more smart. We don't want to repeat ourselves in writing the code. We want the computer to repeat some kind of action, and we want it to be flexible with the input, right? And that's exactly what the loops are for. There are two types of loops, and those are for loops and while loops. Today we're gonna talk about for loops. For loop is something like here in the bottom. So again, we put the word, it's gonna be lead, doesn't matter. And here we have a for loop. Let's read it. For car is a short for character, and in word is the variable here. And then we have a double dot, and then here's an indentation, and here is print character. Well, let's run that, what it does. And look, it did exactly what we wanted previously. Printed first word, second word, third word, fourth word. So this is what we call the for loop. And how does the for loop work? I mean, if you look at this syntax, it's really a kind of a plain English. For some kind of object, we call it a character, in some kind of other object, here we call it a word, do something, print the character. For character in word, now double dot, and now you put a list of what's supposed to do, print the character. Again, for character in word, print the character. And how this for loop works is, so the word is a variable, right? It's a variable, points at some object. We can have lots of different variables, but we have some variables are what we call they're iterable. That means you can iterate through them. That means you can run through them from the beginning to the end. So for example, a word, a real word, is something you can iterate through, right? A word hello, if you iterate through the word, you iterate through the letters, H-E-L-L-O. If you will have a list, if you have a list, like a shopping list, you can iterate through it, right? Shopping list would be one item after another, and you can iterate through it, and you go from the first item to the last item. And exactly the same way it works in Python. You can have here as the, on this position here in this variable, you can have a string, because string is just a list of characters, we talked about it. And so you can iterate through it from the first character to the last character. Similarly, a list. A list is just a list of something. For example, we had lists of numbers, so you can iterate from beginning to the end. Basically what they are doing, right, you take a look at the index 0, then at index 2, then index 3, index 4, and so on. Yeah, sure. And then there are arrays, like a NumPy array, and you can also iterate through the NumPy array. And there is lots of other iterable objects. You cannot iterate through integer, right? I mean, integer 5, what do you want to iterate through it? There is just that integer 5. But if you have a list where integers 1, 2, 3, 4, 5, you can iterate through them, and you can go 1, 2, 3, 4 up to 5. All right. And so if here you have this iterable, so basically it says for, and here you have this variable. Here we call it a car. I mean, you can call it anything you want. Now at this point, this variable did not exist up to this point, and it's going to exist only now throughout the loop. Yeah. And so this is the variable that you're using to loop or to iterate through the object here. So for character, it's a variable character in word, do something. So what Python does is, okay, create a new variable character and assign it the first thing that is in the word, which is the first letter, and then prints the letter, so prints L. Now it loops, that means it goes back again, and it takes the character, again looks in the word, but already it was on the first, it took the first character, now it's going to go to the second character, and again goes here, and what to do with it? Print it. And again, third character takes a so car is going to contain the third letter, and what to do with it? again print it, and so on till there are no more characters, and then the for loop ends by itself. So now again, let's play with this. So here we call it a car, and this is just a for, because here we are going through characters in words. So it's just like we already mentioned before that it's good to give the names to the variables so you remember what kind of variable it is. If you see a code and the variables will be called x1, x2, x3, x5, z7307, I mean, you will have no idea what do they stand for. But if you have a code and one variable is called car and the other variable is called word, you guess that word stands for, they're going to be strings, some words taken somewhere, it doesn't matter where, and car will mean characters, right? So that's what is really nice about this, that you can write Python simply like an English sentence. Even the syntax is very close, right? So for character in word, print the character. But we can change this. We can put here for x in word. And now here we have to again put x, because at this point no car exists anymore, and it's going to do the same. Because this is just a name of a variable, and it just says this variable, take this variable, feed it one by one the entries from the word, and then here is you do something. You can print the x, or you can do other stuff. So let's say, so here we're gonna put a list. List we cannot use because it's a list is a keyword. So list1, and list1 will contain the numbers 2, 3, 5. Okay, and now I can go for x in list1, print x. What it's gonna do, like I just said, this is an iterable variable. That means iterable object, you can go through it and you can pick first guy, second guy, third guy, right? It has more than one value, so you can just go through it. And you don't have to be printing. So like I said, so here is the head. This is what is called the head of the for loop. And so here you're just stating what will be the name of the variable you will use for the iteration and through what you will be iterating. Then you have to have this double dot. If it's not here, we're gonna get a wrong syntax. So this has to be here. And then the code that is below is gonna be part of the loop, right? But be careful, the code has to be indented like this. If we're gonna put it here, see expected and intended block. If you're gonna put code here, expected intended block. So you have to put it here. I mean, it can be lower, you can make a space here, but the first piece of code that is gonna be here, it has to be intended. If you want to continue with the code, of course, afterwards, you can put here a print hello, and that's gonna work fine. But so now, because this part is not indented, sorry, then you get in the for loop, you run through the for loop. Once the for loop finishes, you continue with this code. If you, however, if you indented it, and now you run it, as you can see, it goes in the loop, takes x in the list, first x is 2, print x, also print hello, and start again. Take 3, print hello, and go again. So you see that whatever you write after this head, and it's gonna be indented, that's what is going to happen within the loop. All right. So if it's like this, it's inside of the loop, and so therefore each time you run through the loop, all of this is going to be executed. If you wanted something happen after the loop is finished, you must stop the indentation. And of course now whatever code you're gonna write down here, it has nothing to do with the loop because that's already after here. At this point here already the loop is ended. Inside of the loop, you can write a lot of stuff. I mean, lots of things can happen within the loop, right? So what we can do is, for example, let's create a variable y, and it's gonna be let's initiate it as being a 0. And so in each step in the loop, we can do what? We can do y equals y plus x. So what does this mean, right? This says assign to y plus x. So here you might be a bit confused about this thing that y is on the both sides, but that's because you're kind of looking at it like at a mathematical equation, which is not. It's an assignment of a value to variable. So it says to a variable y, which is on the left, assign the value that is on the right. And the current value, what is on the right. So here you put the current value of y, Python takes current value of y, current value of x, adds them together, and puts it into y. And now we can do, for example, print y. Let's run that. And look what that did. It printed 2, 5, and 10. That's our different numbers that we have here, right? But it makes sense because before getting into the loop, y was equal to 0. Now we got into the loop, x became 2. So here we have 0 plus 2. That's 2. So we printed it and we got 2. Now we go in the loop again. Now x becomes 3. But at this point, y is already 2 from the previous step. So it's 2 plus 3. 2 plus 3 is 5. So you print it, you get 5. Now we go again because x goes here. X is now equal to 5. And y from the previous step is also equal to 5. So it's 5 plus 5, and that is 10. If you have like a hard time to follow this in your code, what you can do is in each step, you can add these print assignments. So let's say for x in list 1, so first I want to know, so I take x. So first I want to know what the x is. And I also want to know what y is before I'm going to execute this. And then after this happens, I want to know again what the print x is and what the y is. And yeah, and let's run that. And now I see it, right? So I start with the for loop here. And so first x is 2 and y is 0. And now x is still 2 and y changed to 2. Now I'm running again. Now x is 3, y is 2, x is still 3, and y is 5. And that really follows that thing, right? That we always go in the loop, x takes one of these numbers, x doesn't change within this code, it changes only when it changes the loop, and y does change here because you take y, you assign y to be y plus x. All right? So this is how you can, so in the body of the for loop, I mean, you can do, well, you can write here whatever it is that you want to repeat. It's another thing that the variable here, the variable x, you don't have to do anything. You can use it simply just for the looping. So for example, I can put here print hello, right? And now you look at this and now you say maybe, this doesn't make sense. For x in list 1, just print hello. Well, it makes sense because what this code is going to do is, it's a for loop. So it's going to iterate through list 1 that has 3 values. In each step, it assigns x one of the values. So x is going to be equal to 2 and it's going to print hello. And then it goes again, x equals to 3 and then it's going to print hello. And x equals to 5 and it's going to print hello. So in total, it's going to print hello 3 times. And there is no x because maybe we didn't care about x. We just wanted to print hello as many times as how many values are in the list. Why not, right? I mean, so that's another thing. This guy here, this variable that you're using to iterate through this iterable here, if it's a list or if it's an array or if it's a, if it's a string, it really doesn't matter. You have 2 options. You might use it. So yeah, maybe you're getting some values, like you're getting characters from letters, and now you want to be doing something with it. Or you don't want it, right? So yeah, so here's a nice one. Actually, that's a solution of one of the first homework which you were supposed to do before the class. So let's say that we have a word. And let's call it again. Let it be again. Hello. Hi. Hello. And now what you would want to do, right? Now what you want to do is you would want the Python to take this word and you would want it to spell it backwards. You would want it to write it backwards. So you would write the word O-L-L-E-H. Instead of hello, you would want to write ole, or something like that, whichever way you want to pronounce that. So how we can go about it? So now we are at the programming part. So now we have the problem. So I have a word and I want it to spell it backwards. And of course, well, I can do it in my head. I just look at the word and I just go backwards, right? But now I want the computer to do it. How can the computer do it? Well, I want to go through each of the letters backwards. And that's one way how to think about it. So I'm repeating the same action, right? Like before going through each character, now I would like to go through the characters backwards. So here, I mean, there's lots of solutions to this, but one way is I can build that word backwards, right? And the solution is, for example, the following. So let's call it a backwards or word back. So so what I just did here, I created an empty string. So this is a string of 0 length. It has no characters, but I'm going to use that. And so now what I'm going to do is I'm going to take a for loop, and that's going to go through this word here. For example, hello. It goes one by one from the beginning to the end. But I'm going to be constructing this word backwards. So I will not be adding these characters in the beginning of the word, but at the, not at the end, but in the beginning. So I will put here again, I mean, it's just a convention. I mean, it's just to make it readable, but you could put here whatever you want. So I put for character in word. What I'm gonna do is that the word back equals, here is gonna be still word back, and now I want to add the character. So if I'm gonna add the character here, I'm gonna do plus character, right? And then here in the end, print word back. So what happens? I'm gonna get a hello again, right? Because here word back is an empty string. Now you get here, I get the first character, that's H, and I'm gonna take what I have already, plus H. And then in the next step, I have H, and I'm gonna get E, and I'm gonna get L, L, O, I get a hello. But look at this. Instead of adding it here, I'm gonna do it's a character plus word back. I'm gonna run this, I got ole, right? Because I'm putting the character in front of what I already have. So in the beginning, there is nothing, it's same, I just get H. But then in the second step, I get E, and I'm gonna put the E before the H, right? So I'm building the word backwards, so in the end, I have the backward word. So here you have a solution, one of the possible solutions for the first homework that you might have been struggling with. So like I said, we can iterate through these iterable objects, meaning that basically through some containers that contains lots of other small objects like the lists and arrays and the strings. But sometimes what we want is we want to run a loop certain number of times, right? That happens. And so for this, if you have a specific number of times in mind, you can use this function called range. So this function called range, let's take a look at it. So range, it can take several parameters. So if you give it just one parameter, and that would be an integer, if you give it just one integer, then range creates an iterable object that contains the numbers from 0, the natural numbers from 0 up to this guy. So let's run this, and so you see that it prints out 0, 1, 2, 3, 4. So this function range took the number 5 and created, let's say, in indices from 0 to 4. So it created 5 numbers and it starts from 0. And so again, you see the syntax is for I in range. So take one of these numbers, and then we put here to print it. This function is kind of flexible. So maybe sometimes you don't want to start from 0, right? You would want to start maybe from the number 2. So of course, one way would be that you could add here, you could put print I plus 2. That's not a problem. Now it starts from 2, but now it ends with 6 and not with 4. So now we would have to also subtract 2 here. And now we would get what we wanted. We wanted to start from 2 and go to 4. But I mean, that's lots of changes here, right? We had to change we had to add 2 here and subtract 2 here. So instead of doing that, we use another parameter in the function. And so if we put 2 integers here separated by comma, what it gives us is the starting point and the ending point. But again, we are talking about indices, so this is not included. So if we're going to run this, this is 2 and 3 and 4. It starts from 2 and it goes all the way up to 5. 5 is excluded. All right. And sometimes maybe you don't want to just do numbers 1, 2, 3, 4, 5 with the step 1. Maybe you want to have larger steps, step 2, step 3. So you just add here a third integer that indicates the step. So if I'm going to run this, right, it printed 2, 5, and 8. So I wanted to start at 2. I wanted to go up to 10. The 10 is exclusive. And the length of the step was 3. So you see difference between 2 and 5 is 3. Difference between 5 and 8 is 3. So I can change this to 2. And now you see it does me 2, 4, 6, and 8. So you can play with that. You can modify this to see how this works. And so yeah, and again, I mean, here in the body can be anything. I mean, this can be used for some calculations, or you don't have to really use that I. If again, so if I want to print hello 5 times, this is the easiest code you can do. You just run the loop, and in each run, you know this loop is gonna run 5 times, and in each run you're gonna print hello. So it's just gonna print hello. So the last thing that we're gonna take a look at is this function len. Len is short for length, and this function works for many different types, not for all types, but basically it works for, again, all these container kind of types, and it gives you the length of the container, or how many things are inside. So for example, if we talk about string, and so we think string is just a list, is a container that just has the characters. So each word has a length. Length of a word for us is how many characters that word has, right? Or you have simply just a list, like here we have a list of integers, and now you would want to know how many of them is there. You can use the len function for both of these. Sorry. And so here, this is something that I already explained to some of you. So here, 6 has been put out. That's not output of this guy, right? It's output of here, because this has length 6, this has length 5. How come they are not both here? Well, that is because this output function, that's specific to the notebook. If you really want to see, if you want to really see always all the stuff on the display, you have to use the print function. So because this output shows only the last variable, but not everything before. So if we put print, so you see length of word hello is 5, length of this is 6. So again, let me change this. So we put here goodbye, length of goodbye is 8, and that's goodbye for today. Thank you.